And my original discussion, what I was saying was, we're calling this the carbonyl diamond ring. See, it looks like a diamond ring. Cool. See, good thing I write these notes down, huh? So this, we're going to call the carbonyl diamond ring. Now, where you got to know your chemistry is because this thing is actually the carboxylic acid, drawn like that, but they draw it with the OH on the end of it. Can I get it up there right in front? Right there, like that, right? Well, that OH is what gets hydrolyzed, makes water in the peptide bond, so now what you're left with is just a carbonyl group up there. That other oxygen's gone, because that bonds to the nitrogen, remember? When along comes a nitrogen over here. So where'd that O go? There were two O's on the carboxylic acid, right? Well, that one went to make water when this boinked together, when the arrow shot in. See the way we do this? So when the arrow of nitrogen shoots into that carboxylic acid part, what comes out is water. One of those O's, H off that, and then it picks up another H, actually a proton out of the water. So that's how that comes together. The backbone here looks just like an arrow, and then you get them coming together, one into the other. See, this is a great diagram when I look at this, because look, see how this has the R on the bottom, this has the R on top, this has it on the bottom, so that shows how these are flipping back and forth. So back to our amino acids here. Here is phenylalanine. Phenylalanine. Here is one with a ring, double ring actually. It's got a carbonyl ring, tryptophan. And these are getting more complicated here now, aren't they? Let's see if we can follow some kind of order here. Tryptophan. Oh, this one here is a proline. Proline forms in on itself to make a ring. So that nitrogen is part of the backbone, actually. So this is kind of like just 3 carbons hanging off, but somehow it goes around that way. So proline is one that you'll see written in different ways. Now we'll come to some more nitrogenous ones. So the simplest nitrogenous one here is going to be lysine. And see how cute this looks on the little end of it there? No, I mean, you can make like a little, looks like a Smurf or something, right? So there's 3 H's. That's like an ammonia group hanging off there, because it gets a little plus charge because it's got an extra bond. That lone pair, instead of having a lone pair, has a proton on it there. So lysine is 1, 2, 3, 4 carbons off, with a nitrogen with an extra proton on there. So that's what you would call acidic. It'll give a proton up kind of easily. Then it would just be like an ammonia hanging off there. So here again, to show the nitrogen alien, I'm going to do this for you kids. I don't like aliens, but it just looks so much like an alien, I can't deny it. So there's a 3-armed alien nitrogen, ammonia. See, we're calling him the Ammonia Alien. And that is right there. See, now when you look in the structure of these things, it gives some character to it. So this is histidine. This is a popular amino acid. And another nitrogenous containing one was arginine. Arginine here. Get right up close. I got 2 nitrogens on the end of that thing. And one's double bound, and it's got an extra proton on it. So this right there is pretty complicated. That one there is simple. That's just the end, H2 hanging off the end. But that right there, double bound to the carbon. Oh, and look, there's another nitrogen. 3 nitrogens surrounding that carbon. This, I got to tell you, you know what? This is one of the coolest amino acids. It's by far one of the most complicated ones, I mean, that's really something, having 3 of those hanging around there. So again, in our later discussions, what we're going to start learning on is on your diet. These amino acids make proteins. So there's essential amino acids. I'll show you those in a little bit to classify these, the ones that the body needs from your diet. The enzymes in your body cannot make those. They can make the other ones from other ones, but they're essential. So protein is what the amino acids are. Our other type of food group is a sugar. The sugar is what your brain works on. So people that are diabetic, or if you get low blood sugar, the first thing that goes is your brain. They faint, right? So sugars are carbons and the OH dots. This is where the alcohol representation is going to come in so popular. The dot. Okay, now these can have different dimension, space occupying things, so they call them isomers, and there's left and rights and alphas and beta connections and stuff. Don't worry about any of that. Okay, this is kind of messed up there. So the carbons, you'll see them drawn in a straight line, but what they'll do in an aqueous environment is they'll circle up. Some technical terms for that stuff I won't go into, lactones or something. Fats are your last food group. Okay, now fats are taking a bad rap right now from the dietitians. Well, I'm here to tell you there's 2 essential fats for one. And what your body does now, it breaks, these come in triglycerides, the 3 greens. These are your carboxylic acids. This is where these can get broken off. This is your water chemistry stuff. I mean, God made this so elegant. Carry these things around, just make water to break that bond. Now you've got what's hanging off there are fatty acids, okay? What your enzymes do will break these down into 2 carbon structures. 2 at a time, they pull them off into acetyl coenzyme A's and stuff. So when you're breaking these down, they get into little beta pieces, they call them. 2 carbons long. Then they go into the cycle of breaking those down to get energy. You get more energy from fat. Fat, again, like I said, is getting a bad rap right now, but it's essential. So you got to eat right. Don't be afraid of the fats. I'm going to put this up here again just to let you focus on the protein. Water is little Mickey Mouse. So kids, I mean, if I'm drawing it like this simple, you kids should know this by the time you get to 5th grade anyway. Okay, then you can start learning some real chemistry. Okay, what we're going to do is these 4 new amino acids that we didn't do last time. So what we need to do is our template. I got some weird paper, like I said, we're recyclers here, so this thing is like 1/8 of an inch longer, so we're going to tune it in up top here. So we need our triangle first, remember? Triangle. And we need our diamond over here. Diamond. Let's get our done with the template. Triangle. I'm being real careful. I see how neat this is. I should put something under it before I make a mess. Diamond in the middle. This is the Schroeder diamond. This is the one we're focusing on. We got that to that arm. This arm went to the bottom, remember? Got double bond on there. That's that carbonyl diamond ring, remember? So here with the N, we're going to give it to you kids. Here's your little alien. Okay, so let's hone in a little bit more on this. Now, the side groups on these, What's interesting about these is, we'll draw the little dots. I know someone out there is saying,